in problem 6, we have the information that t varies with the 3/2 power of r. Now, t is the time for an orbit around a planet. We call that the orbital period. And just to be consistent with common usage, get the camera up there so we can see that, we usually use a capital T for that. And r is the radius of the orbit. And we're assuming a circular orbit. It doesn't work for an elliptical orbit, although there's something kind of close to this that works pretty well. Okay, so t varies with the 3/2 power of the radius. How do we write that as a variation equation? Because that's what the first thing that's asked. Variation equation is t equals k times r to the 3/2. And k is some number that's constant, at least for this planet. Okay? So, we have that information. Now we have additional information. The additional information that if the orbital radius is 6 times 10 to the 4th miles, then the period is 60 minutes. Okay? Now what can we do with that information? Well, with that information, we can plug the value of t and the value of r in and get the value of the constant. Then when we substitute the value of the constant into this equation, we get a specific equation for this particular planet, for all circular orbits of satellites around this planet. So this is the general process we use with any sort of variation. So we say, 60 minutes equals k times 6 times 10 to the 4th miles to the 3/2 power. We need to solve for k. And k is the proportionality constant. So when the problem says solve for the proportionality constant, if you write the variation equation, you have to write it with a proportionality constant. That always has to be there. So let's label it up here too. Proportionality constant is at k, and any variation equation will have a proportionality constant k. So anyhow, we solve for k. We get k equals 60 minutes divided by 6 times 10 to the 4th miles to the 3/2 power. Now, how do you calculate a 3/2 power? This is one of the places where it's perfectly legitimate to use a calculator. I don't like to use a calculator. I like to keep my brain functional. 10 to the 4th to the 3/2 is 10 to the 6th, and that's easy to obtain just by the laws of exponents. It's 10 to the 4 times 3/2, and you should be able to do 4 times 3/2 in your head. You should be able to get the 10 to the 6th out of this with no problem. So that equals 60 minutes over, now I haven't completed the calculation, I've got to do the 3/2 power of 6. Well, the 1/2 power of 6 is pretty close to 2.5. That's actually closer to 2.4 than 2.5, but it's between 2.4 and 2.5. As we know, if we can square the numbers 23 and 25. Not something I expect you to do in your head, but if you can, that's even better. Okay, and 2.5 times 6 is 9, so that, 2.5 times 6 is 9. This is a little less than 9. So I'm going to say this is about 8.8 maybe. So I'm going to say this is 8.8 times 10 to the 6th, and it's going to be miles is raised to the 3/2, so it's miles to the 3/2. And then when we divide that out, 8.8 is going to go into 60 about 7 times. Reciprocal of 10 to the 6th is 10 to the negative 6th, and that's going to be minutes over miles to the 3/2. Now, I prefer that you do everything with the units because that's a really good habit. If you ever should happen to take a physics course of any kind, that's going to be something that's very useful, and it's very useful in a lot of other applications. So it's useful to do, but as long as you get the rest of the calculation correct, I'm not going to penalize incorrect results. I prefer that you still attempt it, but even if you don't, I'm not going to penalize it as long as you get the numbers right and use them correctly. Still, it's a very good thing to be able to do, so I recommend it. Okay, now this gives us our specific variation equation. I call this the general variation equation here. And the specific variation equation is the one you get when you write this equation but replace k with its value, so that we get t equals 7 times 10 to the negative 6th minutes over miles to the 3/2 times r to the 3/2. Now, we can use this equation if we happen to know a value of r. We can use this equation to solve for t. Because if we know the value of r, we substitute that, and the only thing that's unknown is t. Similarly, if we know what period we want, what t we want, we plug that in and solve for the value of r. Now, I don't believe the equation or the problem as stated actually asks you to do that. So I'm going to do that in a sort of an addendum in the next video. The problem as stated in this particular sample test simply asks you to get this equation. It doesn't ask you to then do anything with the equation. So this equation obtained by this process is your answer to that question.